So this was all about self-inductance, but in exam they are not stopping here. They will ask you, if I have a coil, circular coil of radius r with n turns, tell me self-inductance of coil, or tell me self-inductance of a solenoid. What to do? If we are discussing about self-inductance of a coil, just I told you, if n turns are there in coil, n phi is equals to L into I. A basic concept, if you want to calculate self-inductance for coil, if you want to calculate self-inductance of solenoid, this concept is basic. We know this relation. Now it will change according to your figure. Phi is again same, B into A. Flux means area of cross section into flux density. But now it will change according to figure. If you have coil, we know that if I current is flowing in the coil, magnetic field it's at its center, it should be mu naught Ni divided by 2R. What is A? A means pi r square. Cancel I with I and you get the result that self-inductance of a coil is equal to mu naught pi, cancel 1R, mu naught pi n square R divided by 2. So many problems they can frame on this. Once they asked, self-inductance of a coil depends on which power of number of turns. Clearly it is 2. Means they can ask, ki I have a coil whose self-inductance is 2 Henry. By if I double the number of turns in coil, what is new self-inductance? If you are doubling the number of turns, n square means it will become 4 times. So if initially it was 2, now it should be 2 into 4, 8 Henry. So orally you can calculate if you know this relation. In same way, now we can calculate self-inductance of, self-inductance of solenoid. This relation is common. N phi is equals to Li. Learn by heart. Again the relation is same. Phi is B into A. Now it will change. It is solenoid. For solenoid, B is, it is N. For solenoid, it is mu naught Ni. N means number of turns per unit length. So we can write that N by L. Into A. Cancel I with I. We got the formula for self-inductance of a solenoid. Again, it is directly proportional to n square mu naught n square A by L. Getting my point? It is mu naught n square A by L. Now we are going to discuss mutual inductance. One more thing is there. When you have a coil of self-inductance L, Suppose I current is passing through it. What is the power? What is the formula for power related to this coil? Or what energy in this process stored in your coil? So we want to calculate energy of a figure whose self-inductance is L. You know that what is power? Power is voltage into I, E into I. But power is rate of doing work, W by dt. And doing work means changing energy. What is E? E is L into di by dt. Just we saw in previous slide. Cancel dt with dt. Integrate both sides. You will get total work. Work means energy. Integration of L is constant, I di. When current is changing from 0 to I, what energy will stored in that? Integration of L is I square by 2. So we are getting the formula for energy, half L I square. If in a coil, current is changing from 0 to I, what energy will store in your inductance? Half L I square. So now we will discuss about mutual inductance. Mutual inductance. What is mutual inductance? Suppose I have a coil connected with a source of electrical energy. It is a variable resistance, rheostat. By changing resistance, I can change the current. When I will on the switch, current is passing through the coil. It is producing magnetic field. I have one more coil which I placed near this coil, not connected with any source of electrical energy. Only one galvanometer or ammeter is there to check, is there any current in this coil? What will happen if you flow the current in this coil? Now two coils are there, so I am naming them. It is primary coil, which is connected with source, is known as primary coil, and number of turns in this primary coils are NP turns are in this coil, and in this coil turns are NS, secondary coil. Current is passing through only in primary coil. What we will get? Current will produce magnetic field. But lines of force will not end here. Some lines will pass through second coil also. Lines will pass through second coil also. If I will change the current through primary coil, definitely there is a change in flux related to secondary coil. Since flux related to secondary coil is changing, you will find one induced EMF there according to Faraday's law. Since flux in secondary coil, if there are N turns, total flux should be NS phi S. Depends on current on primary coil. If you will increase the current, this flux will increase. If you will decrease this current, this flux will decrease. So when we will remove this proportionality sign, we will get one constant which is known as coefficient of mutual inductance, which is known as coefficient of mutual inductance. Now see what will happen. Faraday's second law. Induced EMF in secondary coil, it should be equal to rate of change of flux in secondary coil. If n turns are there, in each turn you will find this induced EMF. Faraday's second law. Ns is constant, we can take inside. So what we are getting? d by dt Ns phi s. But Ns phi s is equals to MIP. So we can replace it by MIP. So what we are getting? ES is equals to minus M dIP by dt. Same physical quantities are involved there. Volt, current, time. So unit of M is same, Henry or ab Henry in CGS system. You can define the mutual inductance. If dIP by dt is 1, it will be equal to ES. It means EMF induced in a secondary coil when rate of change of current in primary coil is 1 should be equal to mutual inductance of the coils. So in this way we are able to define mutual inductance also. Now we will discuss about mutual inductance of two plane coils, mutual inductance related to two solenoids. Now we will discuss mutual inductance of two coils. Suppose we have two coils, one is primary, one is secondary. For primary coil, number of turns I am taking NP, for secondary coil I am taking NS. Basics are same. It means flux related to secondary coil. Is equal to M into IP. Phi S, flux means magnetic field into area of coil. But magnetic field is due to primary coil, secondary coil we kept in the magnetic field of primary coil. What is the magnetic field? You know that mu naught Ni by 2R, but it is area of cross section of secondary coil, so pi R square. You cannot cancel R with R now, only cancel IP with IP, and we got the mutual inductance pi mu naught NS NP RS square upon 2 RP. Same, if we have two solenoids, primary connected with source, and secondary solenoid. Up to this relation is same, means NS BP NS BP AS is equals to MIP. But now from B it will change. What is BP? Mu naught N number of turns per unit length. So we are writing NP by L into AS. It is for primary. MIP, cancel IP with IP, mu naught NI, cancel this. So we got the formula for M, mu naught NS NP AS upon LP. So in this way we can calculate the mutual inductance of two solenoids. I told you that we are using the electromagnetic induction, this concept, in transformer. What we are doing there? We are using two coils, one primary and one secondary. We are connecting this with alternating current source. Alternating current means which is changing its direction after half cycle. It is known as primary coil and it is secondary coil. Since secondary coil is kept near the primary coil, associated with the magnetic field of primary coil, and we know that induced EMF is directly proportional to number of turns. In primary coil, number of turns is different. In secondary coils, number of turns are different. So if we divide EP by ES, we will get NP by NS. Means in secondary coil, you will get EMF according to this ratio. That's why this ratio is known as transformation ratio. If NS is greater than NP, you will get more EMF in secondary coil what you applied in primary coil. If NS is less than NP, it means you will get less induced EMF, less EMF in secondary coil than what you applied in primary coil. So in this way, this transformer is able to increase the value of EMF or decrease the value of EMF. What is happening when we are generating electricity at some place? See, in Bhakhada Nangal, water turbines are used to generate the electric energy. Now we have to send that energy to another city by conducting wires. Heating effect is there. H is directly proportional to I square, means strength of current is most responsible factor for loss of electrical energy due to heat energy. To reduce that effect, what we are doing there, we are using step up transformer. Step up transformer means there are two types of transformers, one which are increasing the EMF, one which are decreasing the EMF. Which is increasing the EMF are known as step up transformer, and transformers which are reducing the EMF are known as step down transformer. We know that what energy you generate there, power is E into I. power generated there is constant. If you are increasing E, means you are decreasing I. So by using step up transformer, we increase the value of E and we decrease the value of I. And when this electrical energy reached at your city, but at your home you are working at low voltage, means 220 volt for domestic, for our personal use, for domestic purpose, we are using 220 volt. There they are using step down transformer, and at your desired voltage they are sending electrical energy to your house. So it was the use of transformer. So sometimes they are asking this. What is happening in electrical motor? In electrical motor, we are using magnetic effect of current. The coil is rotating in a magnetic field. But if coil will rotate in a magnetic field, due to Faraday's law, there will be one induced EMF which will oppose the cause, which will try to reduce your main voltage supply, because it is in the opposite direction. So what is happening there? In starting, it is electric motor. In which coil, you are passing current through a coil. Since conductors are in a magnetic field, they will experience a torque, they will start rotating. But due to Faraday's law, there will be one induced EMF which will oppose your applied electric EMF. Means if you are applying 220 volt, it will oppose that. Since it is also, coil is rotating with very high speed, so value of E is also very high. This EMF is known as back EMF. So it is controlling the current through coil. Current is E minus E by R. That's why your coil is safe. But in starting, when coil is just going to start, induced EMF was not there. In that case, value of I will increase too much. It can destroy your coil. So for that, we are using starter. Starter means variable resistance. So variable resistance means when you are starting your fan or any electric appliance in which motor is rotating, the resistance will be higher, and slowly when it is getting speed, it will reduce to zero. Now to control the current, that role is taken by this back EMF. So sometimes they are asking problems related to back EMF. So this was all about the theory which we need for this unit. Now one more thing is there. If you are using more than one coils, then total self inductance, how to calculate? Suppose if you have two coils connected in series, and its self-inductance is L1 and its self-inductance is L2. So total self-inductance will be L1 plus L2. And if they are parallelly connected, then you can calculate total self-inductance just like resistance by the formula 1 upon L is equals to 1 upon L1 plus 1 upon L2. We are not taking mutual inductance in account, but if two coils are there, mutual inductance should be there. If you are taking them in account, in this case, you will get L is equals to L1 plus L2 plus minus 2m. Why plus minus? If their induced EMF is supporting each other, then plus. If opposing each other, take minus. Means If coils are like this, induce EMF in same direction, take plus sign. But if they are connected like this, means not supporting each other, means current is flowing this left to right in this coil, but in this coil it is moving from right to left, then you have take minus sign. So it was all about, and one thing, coefficient of coupling. Sometimes in exam they are discussing about coefficient of coupling. When you are using more than two coils, one term is their coefficient of coupling. Okay, how important their combination is, and it is given by m upon root L1 L2. So no unit for coefficient of coupling. For two coils it is given by this. So now we will discuss 45 problem assignment for this unit, electromagnetic induction.